Hello guys, welcome to MoBileMaThS with Kamchirai. Today we want to look at direct variation, looking at nonlinear quantities in particular. So we have some quantities that are nonlinear that we can also look at. For example, I can have a mass of a cardboard squared, which is directly proportional to its area A. If we are to write this, we can have M varies directly with A. And this is a linear variation. Okay, this is a linear variation if we are to consider it like this. But if we are to go into detail, as they have said that we have got a cardboard square like this, we can look at the area of our cardboard. Okay, let's draw the area of our cardboard. So this is our area. I'm taking the dimensions x centimeters and x centimeters. So if we have something like this, then it means if we are to look at this, it means the area of this cardboard varies directly with x squared. Okay, so that is the relationship of our area and its dimensions. Then if we are to substitute this area into our initial m varying directly with x with a, then it becomes we had m varying directly with a, but now we have deduced that a is equal to that. So it means we can have our m varying with x squared. We have substitute for a with x squared. Then when we have something like this, now it becomes a non-linear variation because of that squared. It's no longer a linear where we would draw for relationship of m and x and have a straight line. This time around, if we are to draw the graph, we will have a graph like this. This is the graph that we will have if we are to represent our m varying with our x squared. This is the graph that we have, and this graph is similar to the graph of y is equal to x squared. It is similar to this graph. Let me show you the graph that I'm talking about. It's similar to this one. So in this case, we have got y is equal to x squared. And if you can note, the steepness of our graph is not that steep. It is taking long here. It is not that steep. So that's our graph if we are to represent m varies with x squared. Okay, it's similar to this one. Let's have another example. We can have an example of say let's say we've got let's look at the volume of spheres. Volume of spheres, it is said that the volume of spheres is directly proportional to the cubes of their radii. If we are to write that, we can have v. There is a formula that we use, that is v is equal to 4/3 pi r cubed. Okay, like that. That's the formula that we have. Okay, that connects the volume and the radius of our spheres. So if we look at this whole number here is a constant. 4/3 pi is a constant, and because it is a constant, we can deduce that v varies directly with r cubed from that information that we have, because 4/3 pi is a constant. And if we want to represent this information on a graph, we can have our graph as the steepness this time around will be different from the previous one because of the cubed that we now have. Initially we had m varies with x squared. When it's squared, it was not that steep. Now because we have got v varies with r cubed, the cubed part here makes our graph more steep. It's now steeper, this one, okay, than this first graph that we had drawn. We can have other graphs, for example, where we have got this graph here. This graph represents a variation of y varies with the square root of x. That's the type of graph that you can have when you have something like this. So this information is useful because you can be asked to draw or to sketch the graph of the relationship that you have drawn. Let's have examples, worked examples that we can have from this question. I've got question number 1 here of nonlinear variation. We work it somehow in the same manner from the previous questions that we did in variation 1. Okay, so the question is reading y varies with directly with the square root of x, and we are given y is that and our x is that. The first thing is find the relationship between that. So we write y varies directly with the square root of x. Okay, so we introduce our constant. We have y is equals to k square root of x. Substituting the values that we have, we had 4.5 is equals to k square root of 9, like that. Okay, so if we have this, we can simplify. Simplifying, on my left side, I've got, let me write it as a fraction, as an improper fraction. This is 9/2 is equal to k square root of 9. We get 3. So by 3 this side. Then to get k there, I'll divide by 3 both sides. I'll divide by 3 both sides. So if I divide by 3 both sides, I'll get, for this one, is the same as 9/2 divided by 3/1, which becomes 9/2 times 1/3. And these can cancel off each other. 3, 1, 3 there, 3. So the value of my k there becomes 3/2. Okay, so k is equal to 3/2. Now I can write my relationship. The relationship becomes y is equal to 3/2 square root of x. This is the relationship that we have built. Let's look at the second part of the question. It's saying find y when x is equals to 25. Let's do that. So when x is 25, our y is equals to 3/2. This is part B. 3/2 square root of 25. We get 3/2 times square root of 25. We get 5, like that. So at the end of the day, we'll get our y becomes 7.5. Okay, that's our y. Let's go to our part C. Our part C, we want to find the value of x when y is 6. So we have got when y is equal to 6, our x becomes what? So using the same relationship, we have got y is equals to 3/2 square root of x. Okay, so that 6 is equals to 3/2 square root of x, like that. Now I want to find x, so I'll multiply both sides by 2/3 so that I can cancel off 3/2 by this one. They cancel off each other. Then this one is the same like this, so I can have 3 into 3, 1, 3 into 6, 2. I'll have a 4 this side and the square root of x here. Then to remove the square root of x there, I can, square root is the same as x to the power of half. Okay, it's the same as that. So I can multiply by 2/1. So I'll come here and multiply by 2/1. Okay, so if I do that, here they cancel off each other. Here is the same as 4 squared becomes our x. 4 squared is equal to what? 4 squared is equal to 16. Okay, so it means our x is equals to 16. Then the graph of our information, the graph part D, the graph of part D, they said the graph of y varies with square root of x. We drew that and we concluded that it is similar to this one. This is the graph that we have, y varies with square root of x. Okay, so that's the part D of our question. Let's look at the last example. Okay, so this one is in words. Sometimes we can have questions that are in words and you have to derive the variation relationship. So this one we are saying power, the power P in watts used in the electric circuit is proportional to the square of current C, amps. So if I want to write that, I'll have power is proportional to the square of current, like that. That's the relationship in an equation. Then we are given that when the current is 4 amps, the circuit uses 500 watts. So now we want to find the relationship. That information will help us to find the relationship. So if we are to use that information, it means we can have power. We now introduce our constant P is equals to K C squared. Okay, now we can substitute. Our P is 500 is equals to K. Our C is 4 squared, like this. Okay, so let's simplify and find our K value. So it means we have got 500 is equal to K, 16 this side. So we divide by 16 both sides to get our K. If we do that, we'll get 16 into 500. I'll get 31.25. So it means my K value is equal to 31.25. And the relationship that I can build from that information is that my P is equal to 31.25 C squared. So this is the relationship. And the question went on to ask, find the current when we are given that the power find the current when the circuit uses 420 watts there. Let's find our C. So we are going to use this relationship. So it means our P is 420 is equal to 31.25 C squared. We are going to divide by 31.25 both sides to get our C. Okay, so if we do this, we'll get this side they cancel off. We'll get on this side, I'll get 77.44. Okay, so it means my C squared is equal to 77.44. Now to get my C value, this one is squared, I have to find a square root. I have to find a square root on the other side. So my C becomes square root of 77.44 is 8.8. So when we have when we use this power of 2420, the current is 8.8 amps. Okay, so that's the final thing. Otherwise, thank you guys. Let's meet in next lesson. Bye bye.